Hey there everybody, I'm Forrest, and welcome back to ScienTEST, the show where an actual scientist unboxes, tests, and savagely reviews science kits intended for small children. Holy crap, I have wanted to say that again for so long. It has been a long, difficult, and incredibly stressful couple of months for me, so thank you so much for your patience in waiting for this next episode to come out. But hey, we got some cool stuff out of the wait, not the least of which being this incredible new studio that we're sitting in. This studio is made possible by my patrons on Patreon. By chipping in $3 or $10 or $20 a month, they gave me the first push that I needed to buy the lights and some of the sound foam, and while yes, I sunk a lot of money into this room, we ate some ramen, y'all. I know that without their initial donations, I wouldn't have had the courage to take that big step. So if you're a patron on Patreon, or you want to become one, sincerely from the bottom of my heart, thank you so much for being a part of my dream. And now that we're through all the sappy stuff, let me show you today's kit. Today we'll be testing out the National Geographic Glow-in-the-Dark Science Kit, a part of the Mega Science series. Explore glow-in-the-dark science with putty, slime, crystals, and more. Make your own slime, grow your own crystals, and play with moldable, squishable putty. Then turn out the lights and watch them glow. A detailed learning guide explains glow-in-the-dark science and offers fascinating insights into the worlds of slimes, putties, and crystals. This thing says that you can explore fluorescence with UV light, that you can make slime, and that you can draw on putty, and that sounds freaking rad! So let's pop this bad boy open to see if National Geographic is any better than Discovery. So right away, we've got a few booklets. These look like instructions. We've got a couple of containers that are marked slime, but they don't have anything but, I'm guessing powder in them. We got a freaking awesome rock! Oh, this one's cool. And then we got another rock marked Seed Rock. This is definitely for growing crystals. We're probably not gonna do that one today, just cause I don't have the 5 to 10 days to record that process. But who knows? Maybe we'll set it up and I'll just take a video of it way later and post it on Instagram. We'll see what happens. Then we've got this unfortunately squishy silicone measuring cup. We've got crystal growing powder. That can go over there too. Glow-in-the-dark putty, some pre-made goodness for you. We've got a little keychain. I'm guessing, yep, that is UV light there. A little stand, like a display stand. That's charming. And a couple of popsicle sticks. These are probably just for stirring, so we'll see what we do with those. So let's do it. Let's jump right into these slime instructions. What you'll need: 1 packet of green slime powder, 1 packet of purple slime powder, 2 plastic containers, and 1 wooden stir stick. Got all those things. That's great. I do love how on the front of the instruction booklet here, they've got a full wrap sheet for the chemicals that we're going to be using. It looks like all this really is just polyvinyl alcohol, which is great. That's what I used to make slime with for years and years and years. It's pretty non-toxic. So all of these danger labels just say none underneath. But they do have the USA's poison control hotline here. They have a spot to write in your own local poison control hotline if you live outside of the US. And they have a URL link for the WHO's Poison Control Center. So that's just, I don't know, I think that's charming. Preparing your slime. Good scientists always wash their hands before performing an experiment. This will prevent bacteria growth and prolong the life of your slime. I actually did just instinctually wash. Man, that's creepy. Years and years of labs are coming back to me all at once. Dr. Lou always told us to wash down your workbench with ethanol before and after every experiment, just in case. I don't like that the instructions told me what to do. I mean, that's the whole point of instructions, but I don't like that they told me what I already did, you know? Big mark against this kid. It very accurate, but very creepy. Measure 2/3 of a cup of warm water into a dry mixing bowl, one that will be easy to clean later. Yeah, after the gummy experiment from last time, I'm just gonna use disposable bowls. Okay, and it looks like we're also gonna need some scissors and whatnot, so I'm gonna go grab everything that we need. I'll be right back. But thanks to the magic of editing, you won't even notice a difference. Here we go in 1, 2, 3. I'll go get the stuff. We'll just pretend like that went really well. Now the first thing we're going to need to do is add 2/3 of a cup or 160 milliliters of water into this bowl. My measuring cup is in the dishwasher right now, but that's perfect because we just have glassware about at this moment. You didn't think this stuff was going to come in handy, did you? Here's 100 milliliters right here. Remember when measuring with a graduated cylinder like this to always leave it flat on a table to make sure you're not tilting it, and always measure from the bottom of the meniscus, which isn't an issue with a wide one like this. The cool thing is I actually didn't want to record today because I wanted all of these full with like pretty colored rocks instead of just kind of half full like how we've got it right now. But hey, it worked out. Next, we're going to open our slime powder packet and then slowly mix it here into the water. Vote now in the comments below. Do you think that we should do purple slime or green slime? Let me know and we'll go with whichever one you guys vote. I can't read the comments before I post the video. You know that. Do you know how many channels do that? They take advantage of children to get extra comments. They tell them to write as if they can, like Dora the freaking Explorer. It's unethical, y'all. It's unethical. I'm gonna stick with green because I think it'll show up better against like the blue and the black background here. With the equipment that I'm currently using, color correction just isn't an option. So I want this to really pop for you guys. While stirring, gradually add the slime powder into the mixing bowl. To keep it from clumping, stir steadily and vigorously, being careful not to splash anything out of the bowl. Keep stirring until the slime reaches the desired consistency. This should take anywhere from 3 to 7 minutes. Okay, that's not bad. Keep in mind that this is a genuine science experiment and that some batches will need more powder, some less. Pay careful attention while you're stirring and stop once you have the consistency that you want. The entire slime packet may not be required to achieve a good consistency. It's supposed to be sticky and gooey. Well, that's awesome! What a good thing to teach kids. Make sure that they know that things don't always go according to plan and things don't always go according to the instructions. That's actually a really good lesson for scientists to learn. Oh yeah. Oh yeah. That's a familiar smell. So what we're doing here is mixing polyvinyl alcohol into this water. Polyvinyl alcohol is a polymer. That means it's a molecule that's like a long chain with lots of little parts called monomers, sort of like beads on a string. And polymers are great for making slime because they're these long chains that can get all tangled up and gummed up together. Usually you need some sort of a cross-linker to make that happen. And that can be anything like maybe borax or starch is another really good one. You can actually do that at home if you want. Just grab some Elmer's white school glue. That's called polyvinyl acetate if I remember correctly. Mix it with a little bit of food coloring and then pour in equal amount water and laundry starch, which usually comes in a big blue or pink bottle. You'll make slime instantly and it's a lot of fun to play with. Man, this stuff is just everywhere. Oh, that's good. If you wanted to do this one at home or in a classroom or something, I would recommend having each student like write out a little table of 1 minute, 2 minute, 3 minutes, maybe even 30-second intervals, and just noting how the consistency is changing little by little as we go along. Maybe they can find that critical moment where the chemical reaction really starts to happen, and you can even plot out on a graph like how the consistency has changed over time. That'd be a great way to introduce kids into science. Plus, this would be a great way to explain the difference between a chemical and a physical change. That'd be really cool. We are quickly approaching the slimy phase. This is going very well. This is what you want, man. This is what you want to see. This is what kids are into nowadays. Children and slime. Ooh, girl. I loved slime when I was a kid, and I never got out of it. That's why I became a biologist. Do you know how many slimes there are? Literally every kind of living creature produces some kind of slime. You produce a few kinds of slimes. Snot's a slime, earwax is a slime, your spit's a slime. Slimes are just great, man. They're a lot of fun to play with and learn with. Oh, yeah. Ah, it's lumpier than it should have been. Oh, that is some alien innards there. That's great. Tell me you're not jealous. Tell me you're not jealous. Sitting there at home, watching this on your phone or whatever, like, oh man, I wish I could goo that slime about. You can. All you gotta do is make it. What we got? That's not bad. That's not bad. Oh, there's some chunks. That's not bad, though. You guys want to hear a sound? All right, let's get the instructions out of here, and let's just for a second, let's just break the rules for a minute here. Another cool thing you can do if you have like a class full of kids that are all making their own slimes, have a slime Olympics. See whose slime can contain the best bubbles, like stick straws in it and stuff. See whose slime slides faster down like a tilted board. See whose slime is bouncier and can bounce higher. See whose slime can hold more paper clips in it. It's like anything you want to do to make it a contest, kids love that stuff. Oh yeah, like taffy. You just keep it moving, keep pulling it and stretching it, letting it aerate, letting it dry out, letting it all come together. That's what you want. That's what you want. Ooh, or if you have like a bunch of different colored slimes, you could do like slimes in love and have them break off a little piece of their slimes to mix them together and teach kids all about primary and secondary colors by mixing like red, blue, and yellow slimes to make all sorts of different colors together. Or mix all the slimes and see it all turn all horrible brown, black, gray, and talk about the difference between like pigments mixing and lights mixing. You could show how like rainbows come out of white light, but how when you mix different colors together that's a pigment like this, it all just turns black. Talk about the difference between like reflection and absorption and light. You could do a lot of cool experiments just by like playing with slime. And then you give it a little neck and a little head, like that, and just like that, look, it's a swan. Give it 2 little bulbs here, kind of split it in the middle, like a little legs, and it's nice and fluffy in the body, and you turn it over, and it's a sheep. Call this one the Awful Tower. A snake. It's a rocket ship. I am a grown man. Well, this one went super well. Are there any other instructions in here? Nope, we just repeat the instructions in French, German, and Spanish. Un buen científico sabe que siempre hay que lavarse las manos antes de realizar un experimento. I only speak some Spanish because I live in the South. I really need to practice, apparently. Un bon scientifique lave todas ses mains avant de realizar une expérience. Woof. Un guter Wissenschaftler wascht sich immer die Hände, bevor ein Experiment durchführt. I'm actually Austrian. My dad came here when he was a little bit younger than me and never taught me German. So that last one was his fault. He's dead, but oh, he'd be ashamed. Let's move on now to glow-in-the-dark putty. Glow-in-the-dark putty bends, stretches, and bounces just like other putties, but with the included UV light, it also glows in the dark. So we've got our little can of putty here, and we can crack that open, and it's just ready to go right inside. Even has like a nice perforated container there, so we can get into it. Oh yeah. Oh, it's waxier than you want it to be. Oh god. Oh god. Oh, it's like I'm kneading a candle. Charge the putty by exposing it to a light source, such as a light bulb or the sun. The longer you expose it to the light, the longer and brighter it will glow. Once you've charged the putty, turn off the lights and be amazed! So what they're talking about here is just basic phosphorescence. The more that you charge this putty up, the more it will start to glow in the dark. It says to just expose it to a light source, which would give it a small amount of charge, but like really, the UV light is the way to go. But we're gonna try it out the way that it says. It is currently nighttime, so I can't use the sun, but I do have these awesome new studio lights all over the place, so we'll just give this a little charge and then turn off all the lights and be amazed. All right, I am now holding it up in front of the camera. Are you be amazed? Right, well, it did glow a tiny bit. I don't know if you could see it on the camera, but definitely like would have been a lot better if I had used the sun. And here's why. The thing about UV light is that it's super duper energetic. And when that high energy light hits the atoms in this putty, it excites the electrons up to a higher energy state. And while they're up there, it's really unstable. So they naturally just fall back down to a normal stable ground state. And when they do, they release a little bit of the light that they absorb from this ultraviolet radiation. Now, obviously there's no such thing as a perfect system. There's no free energy. So you lose a little bit of energy every time due to just entropy. But that's how glow in the dark things glow. It's what we call phosphorescence. It's when something absorbs high energy light and then releases it slowly over time. And you can compare that to, for example, fluorescence, which is when things glow under a black light. That's when they absorb the high energy light and then immediately release off some light. So the second the black light turns off, they turn off as well. So when things glow immediately under UV light, that's fluorescence. fluids, when they glow for a long time after being exposed to UV light, that's phosphorescence. And if we smoosh this putty down into a nice, thick, flat surface, and then use our little keychain, I can show you what I mean. Do a nice V and an L. Valkai Labs. You can buy a t-shirt in the merch store. Well, this works really well. This is freaking sick, and it comes pre-prepared. I would have liked to have it be something that you can make on your own, but some of those chemicals might not be something you want to give to kids. So I totally understand why they would just have this in a container like this. And last but not least, let's check out this learning guide to see what kind of science this kit actually wants you to know. Right off the bat, they've got all sorts of cool stuff about crystals. What is a crystal? By definition, a crystal is a solid structure formed when atoms or molecules line up in regular three-dimensional patterns. The salt on your dinner table, the snow on the ground, and diamonds in a wedding ring are all crystals. The actual word crystal comes from the Greek word chrysos, meaning ice cold. I didn't know that! Next page, they've got a putty learning guide. This is all about non-Newtonian fluids right here on the front page. Non-Newtonian fluids mean that they're fluids that don't behave in ways that classical mechanics, written by Isaac Newton, would say that they would. Because Isaac Newton wrote out all sorts of different laws about how liquids behave differently depending on the pressure or the temperature that they're subjected to. But non-Newtonian fluids kind of change the way that they act. They'll act more like solids if a lot of pressure is applied to them all at once, a lot of shear stress, as you would call it. So for example, cornstarch and water. You can pick it up and let it ooze through your hands like a liquid, but then if you punch it, it's a solid and you won't go into it because as you hit it, it changes its density in such a way that it's more like a solid than a liquid. And that's how non-Newtonian fluids work. It's super cool stuff. And this looks like it's going to explain it pretty well. Believe it or not, the ball of putty you made is a liquid. It has no fixed shape of its own and slowly flows to fit whatever container it's in. That's absolutely true. A lot of people think that liquids always are just going to behave like water, but really, anything, any cluster of atoms that isn't a gas that can just fill whatever container that it's in, that's strictly speaking a liquid. So yeah, this putty right here, that's a liquid. What makes something glow? All light is a form of energy, so to create light, you must supply some form of energy. There are two common ways for this to occur, incandescence and luminescence. So here they're talking about those differences that we talked about before. Incandescence is energy that comes from heat, so as you get something hot and it glows. Strictly speaking, anything with any kind of heat at all will produce light. It just might not be light that you can see. So for example, I am not hot enough to be glowing, but if you looked at my body through infrared light, which is a light wave that's just slightly outside of the visible spectrum for humans, you would still see me just fine. And in fact, there are plenty of animals that do that. For example, pythons. A lot of python species have these big pit organs all over their face that they use to see body heat by looking at infrared light that comes off of your body. That means that that animal is literally seeing colors that you can't see without even using its eyes. And that's freaking crazy to think about. Luminescence is cold light that can be emitted at normal or lower temperatures. In luminescence, some energy source kicks an electron of an atom up out of its normal energy state into a higher energy excited state. The energy, yeah, we already talked about all this, yeah. Luminescence can be caused by chemical reactions, like the glow sticks sold at amusement parks. It can be caused by radiations, like old glow-in-the-dark clocks, where the numbers were painted with radium-infused paint. It can be fluorescence, where ultraviolet light triggers the release of the excited electron's energy. Hold on. Yeah, they just left the word phosphorescence out. They explain what phosphorescence is, but didn't use the word. And then they used the word fluorescence, but really didn't give a really detailed explanation of the difference. That sucks. So just remember, you've got two major ways to produce light. On the one hand, you've got incandescence. That's hot light. That's how like a light bulb with a filament works. The filament gets really hot, it glows, it produces light. Then you've got luminescence. That's cold light. And there you've got two different subcategories. Fluorescence, where something absorbs high energy light and then immediately puts it off again, and then phosphorescence, where it absorbs high energy light and then slowly releases that energy over a long period of time, what we call glow in the dark. I'm not sure why they didn't make that distinction, but like it's not a terrible thing. They didn't make a horrible, egregious error here. They just Kinda didn't explain this as thoroughly as I would have liked to, but I'm also a huge nerd, and this is literally for children. They even have some little bonus experiments here, just like some questions for the kids to kind of explore the properties of slime, which I absolutely love, because very often this is just seen as a toy, but there's a lot of learning opportunity here. So it says, when you pull your slime slowly, does it flow smoothly in your hands? When you pull it harder, does it fight back? Does it break apart? Sink your fingers into the slime slowly, then push them in quickly. Which method met the most resistance? Does your slime bounce? What kind of non-Newtonian fluid does the slime most resemble? These are great thinking questions to kind of get the kids understanding the properties of this material more than they're just playing with it and having fun. Playing with it and having fun is the gateway drug to science, and this kid is doing a really good job of kind of bridging the gap between fun and learning. I actually really enjoyed this kit. It didn't have a lot going on for it, it wasn't very long, but it didn't overstay its welcome either. It's got 2 good slimes that we get to make, it's got 1 good slime that it makes for us, and it's got an awesome little booklet that has a lot of really great information. I didn't get to read a lot of this. There's a history of slimes in here, there's a lot about Isaac Newton. Like, this is a great jumping off point for kids who want to learn a little bit more about the chemistry and the physics that they were just playing with. And my only real grump with it was that it didn't have enough explanation and the right definitions for this and that, but it didn't have anything in here that was actually wrong. It just could have been a little bit better for me, and I'm very, very picky about things like that. So, like, honestly, I don't have any major complaints with this. National Geographic, man. This is really cool. Like, Discovery didn't even care, and they didn't even feel bad about how much they didn't care. But National Geographic apparently actually gives half a crap about education, and that makes me very happy.
If anybody is watching this from National Geographic, or maybe you know somebody who is from National Geographic, maybe you want a wildlife presenter or some sort of a biologist to talk about life, or just like maybe even just narration, you know, voiceover, presenting, talking about animals, talking about plants, talking about bacteria, talking about fungi. Hi, my name's Forrest.
Well, this has been a great episode. This went so much better than the last one. I can't believe it. And I can't wait to do the next one. I've already got a couple of great kits lined up that I'm very excited about. So thank you so much for tuning in, for liking, for commenting, for subscribing, and all the other stuff that you do here on YouTube. I'm Forrest, the Renegade Science Teacher. Have an awesome rest of your day and never stop learning. See you next time. Bye-bye.